Welcome back again to the H2O Spirit channel. We are going to continue from where we stopped in our previous class. Like I told you, we are still on refraction of light wave. Okay? Now, remember in our previous lesson, we talked about the refraction of light wave through a rectangular glass prism. So today we are going to be looking at the laws of refraction. If you want to solve problems involving calculations involving refraction, you must first of all consider the laws of refraction, and that's what we want to do right now. Now, how many laws do we have? How many laws do we have for the refraction of wave? There are basically two laws, and as it is stated for you on the board, you see that the first law of refraction states that the incident ray, I showed you what incident ray is, the refracted ray and the normal at the point of incident all lie in the same plane. What does that simply mean? It means that your incident ray, your refracted ray, and your normal, they are found in a particular diagram. It's not like you're having incident ray separately from refracted ray. They are all found in a single diagram. Now, the second law of refraction says that the ratio of the sine of the angle of incident, which is I. Remember I told you in our previous lesson that the angle of incident is I, okay? So the sine of angle of refraction, which is arrow, is constant for a given pair of media, as you can see on the board. So please, I want you to master this, master the first law of refraction and the second law of refraction. And then we are going to be looking at the second law of refraction. Let's break it further so that you see what we are talking about. Now, according to the second law of refraction, don't forget, the second law of refraction is also called Snell's law. Please take note of that. It's also called Snell's law. The second law of refraction is also called Snell's law of refraction. Okay? Now, what does the law state? It states that the ratio of the sine of the angle of incident to the sine of the angle of refraction is constant for a given pair of media. So, according to the second law of refraction, we have that our constant will give us sine I over sine r. Don't forget, this I signifies the angle of incident, and that's what your incident ray is. This arrow signifies the angle of refraction, and that's where your refracted ray is. If light moves, remember in our previous diagram, I drew a rectangular glass prism for you. I showed you that if you have a ray that strikes a prism this way, that the angle here is called the angle of incident. So this is your incident angle. And then if the light bends this way, the angle here is called the angle of what? Refraction. It's very easy to learn, very easy. Okay? And then if you have another ray, I told you this ray is the refracted ray that emerged out from the prism. So you have the angle of emergence here. Remember, your angle of incident and your angle of emergence, they are the same. But you have two angle of refraction. You have one here, which is arrow 1, and another one here, arrow 2. Okay, you can check my previous video on this. I drew a diagram where I showed you the angle of incident, the angle of refraction, and the emergent angle. Okay, according to the laws of refraction, the second law, which we also call the Snell's law, remember I said it is the ratio of the sine of angle of incident to the sine of angle of refraction is constant. This symbol here signifies your refractive index. Your refractive index. That is to tell you that your refractive index is the ratio of the sine of the angle of incident to the sine of the angle of what? Refraction. Okay? Your R here signifies angle of incident. Arrow signifies angle of refraction. Refraction. Please make no mistakes about this. It's not reflected angle. No, it's refraction. Reflection is observed in mirror. Refraction is observed in lens and glasses. So please take note of that. So if this is your refractive index, this is your angle of incidence, this is your angle of refraction. Like I told you, refraction only occurs when light moves from one medium to another of different density. It can be from air to glass, or it can be from glass to air, or it can be air to water, or water to air, even from water to glass. And in this formula, we are going to be looking at various derivations from the second law of refraction if our light moves from air to glass. Please take note. If the light moves from air to glass, we are likely going to get something like this. We are likely going to get something like this. Our refractive index, which will be from air to glass, will be the sine of angle of incidence in the air, okay? All over the sine of angle of refraction, which will now be in our glass, okay? Then you can also have that your wavelength of the light in air, that's why you have it this way, air, wavelength in air over your wavelength in what? In glass. Or you can further have the speed of light in air over the speed of light in what? Glass. The only variations you will not get is frequency. Remember in our previous video, I told you that when refraction occurs, your frequency is what? Constant. So there's nothing like the frequency of light in air and the frequency of light in glass. No, you only have that for wavelength and what? And speed. So take note, I'll bring it back again to you, that frequency is what? Is constant. So if the frequency of light in air is 5 raised to the 5 times 10 raised to the power of 2 Hz, the same frequency will also be for that of what? Water and glass. So frequency remains constant, but your wavelength and your speed varies. Okay, so please take note of this important formula. This is when light moves from air to glass. So this is the refractive index of glass. You have sine I over sine arrow, angle of incidence, angle of refraction, wavelength of light in air, wavelength of light in glass, speed of light in air, speed of light in glass. Take note of that, okay? We have come to the end of this video. In our next video, I'm going to show you how you can use this formula to demystify problems on refraction of light wave. Okay, if today is your first time for coming across in the H2O Spirit channel, please don't forget to like, subscribe, click your notification bell so that whenever we come online again and send more videos, it will get across to you. Thank you very much until I see you in our next video.